Good morning to all. Today we're going to see a topic called industrial robotics in the subject CAD/CAM and automations. As per the Revolutions 4.0, the robotics is one of the major topic. Here, how the robotics will help in the manufacturing and productions. We'll see it on this today's session. Where the sections will going to discuss on robot anatomy, the robot control system, end-effectors, industrial robot applications, and robot programming. All five parameters are very important in the robotics subject, where the industrial robot is defined that a general purpose programmable machining and then certain atomic characteristics. We know that robotics is defined to minimize the human work. Here, the industrial robot will help in all the places, I mean, all the industrial places to minimize the error and also the quality of the work and also the machine's work. The Some of the points has been seen to how the industrial robot will help hazardous work environment, repetitive work cycle, consistency and accuracy, difficult handling task for humans, multi-shift operations, reprogrammable, flexible, and then interface to other computer system. These are the things where we tough in the manufacturing unit, where this industrial robot will help in these all areas to minimize the all the troubles and the difficult process. Where robot anatomy is nothing but the joints and then the links which are as like the human hand and the mindset, where we robot anatomy is also one of the important considerations in the industry to do the purpose. Here, where the manipulator consists of the joints and links, the joints provide relative motions, links and rigid members between joints. Various types of joints has been used in the robot anatomy. And main point in the robot anatomy is the degree of freedom, where we have 5 or 6 degrees of freedoms. The robot arm will rotate to pick and place the object to continue in these manufacturing processes. The robot manipulator consists of two sections: body and arm and the wrist assembly, where body and arm is the major. This is the body on the arm, where this is the end of the arm. It will rotate in make the robots work. Then wrist assembly we can make it as on a different types of wrist assembly. We can fix it as per the applications or the work to be done in the bed or manufacturing bed, whatever the work we giving to the robot. Then manipulator joins translation motion. We have these many types of translations, I mean joints are available: linear joint and then orthographical joint, rotational joint, and then twisting joint, revolving joint, where these linear joint will be the to and fro of the manufacturing places, and the joint motions is like input link and output link. Orthogonal, right? Rotatory, we can rotate as per the axis where the work to be done. Then twisting, it is like tilting the uh, work, I mean joint. And then revolving joint, it will be rotate on the axis 360-degree. Then joint notation scheme, where use the symbols like L, O, R, T, linear, orthographical, rotational, twist, and then things. These are some of the codes we used in the joint notation scheme. And then polar coordinate body and arm assembly, where this is the consist of sliding arm actuator related to the body system, which can rotate about the vertical axis. This is the arm which has been connected to the body and the arm. And then cylindrical body and arm, where this is a vertical object, and it will be helpful while we do the complex work in the assembly unit. Cartesian coordinate body and arm assembly. This is like we have been seen in the layout of flexible manufacturing system. This is almost like the same thing, where here we're using the robotic arm and the wrist. Joint arm robot, where here this is the robotic manipulator, and this is the arm and this is the wrist, where wrist can be, or is nothing but the rotational wrist, where it will rotate as per the requirement. SCARA robot. I think we many knows that how this SCARA robot will be like a joint armed robot, which uses on vertical axis. Use it for the shoulder and the elbow points to be compliant in the horizontal directions for the vertical insertion. Wrist configuration, and the is attached to one end of the arm. End effector is attached to the wrist assembly. This is the roll, yaw, and pitch. These 3 degrees of freedom will be considered in the wrist configurations. Thank you.